Okay, so welcome and thank you for joining us today. My name is Sharon Farber. I lead product marketing for data identity and AI security at Palo Alto Networks. And together with me today is Ronnie Yaari. Ronnie is a principal product manager at Palo Alto Networks, responsible for AI, software, security, posture at Palo Alto Network. Ronnie, thank you for joining us today.
Hi Sharon, hi everyone.
So in today's session, we're going to explore the critical components of AI systems. We're going to learn how to identify vulnerabilities in the data pipelines. And finally, we're going to learn best practices for building and securing AI-powered applications across multi-cloud environments. 2024 was a big year for enterprises diving into multi-model AI and LLMs. Nearly all organizations surveyed, 96% to be exact, said they were planning to use AI. However, 62% of them, almost two-thirds, use AI for internal-facing projects, although we certainly see the shift to external-facing projects trending as well. Along the way, we learned that deploying AI applications at scale in large organizations is not a walk in the park. It requires a whole new stack and the ability to handle massive amount of training and vector data. Today, we're going to unpack what this means and how organizations can tackle these challenges. So, Ronnie, with 2025 already here, and given your close relationships with security professionals at large and medium organizations, what do you see as the biggest trends shaping how organizations will approach deploying AI in 2025?
Yeah, thank you for the question. I think we're at a point where everyone realizes the huge potential of AI across industries, across different use cases. So, like you showed us, organizations want to adapt AI, whether it's by using third-party applications or building their own AI applications. So I think these trends are not going to slow down anytime soon. But with this huge potential, there's a big challenge for security teams. And I definitely hear from security professionals that they are concerned about AI security, and going into 2025, they are prioritizing securing AI applications to make sure the adoption of AI is successful and safe. But that's not easy with everything going on with AI and things moving so quickly. The use of open source models, the rise of agentic AI, the increase in regulations around AI. Security teams really need to step up the game and make sure they catch up with everything. And I hope that today we'll be able to offer some initial guidance.
Absolutely. That's exactly what we're here for today, to give security teams the edge that they need to address AI challenges head on as we move into 2025. So let's dive right in with our first question to you. What are the key components and architecture of AI application development systems?
Yes, so when we go into look at AI applications, there are some key components that we need to be familiar with. And first is the model. It could be a large language model, which is very popular today, or a small language model, or any other AI or ML model, which is basically the brain of the system. But in order to communicate with the model, we need the model endpoint which interacts with it. Next, we have the application layer. The application communicates with the model endpoints. It sends the prompt to the model and receives the response. The prompt can come from an end user, from another application, to be created by the application itself. And then we receive the response from the model. But of course, we want the response from the model to be as accurate, as relevant as possible to our specific application. And for that, a very common practice is to use a process that is called retrieval augmented generation, or RAG. RAG is basically adding additional context to the prompt when I send it to the model. And for that, I need to find the relevant information as the context to this specific prompt. So you can think of RAG like a search engine that finds the relevant information, and it does that using data embeddings that are stored in a vector database. Now, going back to the model could be a foundational model, a base model that we get out of the box ready to use from the large research labs like OpenAI, Anthropic, Google, and so forth. And another option is to create our own model, train it on our own data to make it very specific to our use case. But there's a third hybrid option where we take a base model and we fine-tune it, add another layer of training using our own data. And here you can see the process of training the model, starting from collecting the data and preparing it with different types of data, and the iterative process of training the model. So you can see how important data is in this AI ecosystem, and we'll see that also in terms of security, data is very important when we talk about AI applications.
Thank you for breaking it down so clearly. It's fascinating, in my opinion, how each component plays a critical role in creating such a robust AI application. And building on the components and architecture that you just described to us, let's shift our focus to the specific risk that they face. Can you elaborate on the key vulnerabilities in these pipelines and how security teams can proactively identify and mitigate these risks?
Absolutely. I want to take you through a few examples for risks specific to AI applications, but let's start with something that you probably are familiar with, data exposure. So of course, if we train our model using sensitive information, whether it's privacy information about our customers, proprietary information that belongs to our organization, there's a risk of this data being exposed in the model responses. So we need to be very cautious when we train our model on sensitive information. Because the results of data exposure we know could be very severe, from fines to privacy breaches or identity theft. So we need to be very careful about the data that we use. So the mitigation in this case will be to closely monitor any data that goes into the training of the model to make sure it's not sensitive, and if it is sensitive, we will want to sanitize it, to anonymize it, to make sure we minimize the risk of data exposure. So we talked about data exposure, and I want to touch another risk that relates to the data, but this time let's talk about model poisoning. So again, our model is based on the data it was trained on. So imagine a scenario that an attacker poisons some of the data that we use for training, which means that the attacker can impact the behavior of the model. It can lead to the model behaving in a way that serves the attacker objectives, making incorrect responses, creating misleading information, and so forth. And it could be very hard to detect because research shows that even poisoning less than 5% of the data can significantly, dramatically influence the model behavior. And of course, in critical applications like healthcare, autonomous driving, that could be very severe if the model starts behaving unexpectedly. So to mitigate this risk, it's very important to secure the training data, the training process, and make sure it is not being poisoned. Let's talk about another risk, and this time I want to touch on the subject of open source models. We see that they are gaining popularity. There are very popular sites and repositories like Hugging Face that developers can go in and get their model. And like any open source software component, it comes with additional risks. The model can include backdoors that might trigger in certain situations. The model might spread misinformation or, of course, risk the reliability of our critical system. Maybe it includes a vulnerability like remote code execution and so forth. So we really need to be careful when we use an open source model, specifically in safety critical applications. It can impact the application as a whole. So to mitigate this risk, it's very important to validate and make sure all the models we use are vetted and safe. And throughout the AI development pipeline, make sure we have the important checks to make sure all models are safe.
Thank you. So what I'm hearing is that these risks really highlight the importance of practices like data sanitation, securing the training process, and a thorough model vetting to keep AI systems safe and trustworthy. Now, speaking of which, you mentioned before AI agents, and there's a lot of buzz around AI agent now. So could you share a bit about what these are, the risks with using AI agents at scale, and how those risks can be mitigated?
Yeah, sure. So AI agents are AI applications that can make decisions and take actions. We give them API access to different tools, third-party systems, and with great power comes, well, great risks in this case. So when an agent is compromised, there's a risk for it to gather sensitive information, spread misinformation, disrupt any services, or execute unauthorized commands. So there's a significant risk for operational disruptions if an agent goes out of control. And to mitigate this and make sure our agents are not compromised, we really need to implement robust security measures and closely monitor all the permissions that we give to our agents. We will want to implement the principle of least privilege to give the most minimal permissions necessary for the agent and closely monitor if anything changes, and of course to be able to identify any abnormal behavior to identify an attack.
This is very helpful. And so next we finally are at the best practices part. And we want to hear from you, what are the best practices for protecting data and identities when developing AI applications, how organizations can unlock this tremendous business opportunity that AI brings, but at the same time, not compromising security, efficiency, and scalability.
Yeah, that's a very important question. And I think the first thing I would recommend for everyone to start doing tomorrow morning is to map your AI ecosystem across the different clouds, the different services. Just make sure you have full visibility to all the components, the models, the applications, the data set. Because like we say, you can't protect what you don't know. So it really starts with this layer of visibility. For example, if we talked about risky models, you won't be able to verify your models if you don't have a complete inventory of all the deployed models in the environment. So that's the first thing. And next, I would look into applying guardrails. Both on the inputs that goes into the model and on the outputs that the model generates. And a guardrail, for example, is applying prompt injection protection. And you can use out-of-the-box solutions from the AI managed services like Bedrock or Azure OpenAI. You can use third-party solutions or build your own guardrails, but they are very important to apply to minimize the risk of an attack. Next, again, I can't stress it enough, the importance of data. When it comes to training and fine-tuning models, you really need control over the sensitive data that goes into the training of the model. So classify any data that is used for AI to identify any sensitive information. And last but not least, it's very important to discover all your RAG workflows. Again, they involve data and map all the connected services. And I think that by integrating these best practices, organizations can build a secure AI application that maintains both data integrity and safeguards against potential risks.
Thank you. So now we've covered the risk and how to mitigate them. We have in our audience many security professionals who are actively looking for the right tools to tackle these very challenges that you just spoke about. So can you give us a rundown on one such tool, the Palo Alto solution for ensuring AI posture security?
Yeah, I'm so excited to have this opportunity to help organizations protect their AI applications because it is a real challenge. So our product, our AI Security Posture Management, it analyzes the AI ecosystem and identifies any risks and misconfigurations in order to prevent attacks and reduce their potential impact. We start with automated discovery of all AI application, models, data sets, and all associated resources. But we don't only stop at discovery, we also map all the relationships between those different components, so you have a full inventory of the environment and you can understand how different parts in the AI pipeline impact each other, specifically how they impact data. And next, we look at the different risks, like the ones we talked about today, misconfigurations, supply chain issues, and we map all those risks into known frameworks, such as the OWASP Top 10 for LLM. Because we know that as regulations around AI continue to continuously evolve, AI-SPM can really help organizations stay ahead of compliance requirements and start embedding them early in the AI development process. And finally, we do full data security across the AI ecosystem. We integrate with our DSPM product, our Data Security Posture Management, to make sure you know exactly what data goes into the model. We classify the data so you know whether it's PII, PCI, or any other sensitive information. And this insight can help you prioritize the risk, because a model that contains sensitive information will probably will need more attention than a model that doesn't include sensitive information. So I'm happy to say that our AI-SPM is already battle-tested and identified and prevented real-life risks for large enterprises.
Ronnie, thank you for guiding us through the challenges and best practices of working with and developing AI application. It's been truly insightful and engaging. And to our audience, we hope you found this session both interesting and valuable. We encourage you to connect with us on LinkedIn to keep this conversation going. Thank you, and bye-bye.